general formula for this alcohol, phenol, and ether functional groups. Fine. So first of all, we have to learn about this alcohol. Okay. We will learn its classification. How it will be classified? Can you tell me? Any idea you have in your mind?
Based on primary, secondary, and tertiary carbon.
Okay. Apart from that,
I don't know.
okay.
Acidity?
Yeah. Apart from that, it can be classified on the basis of number of hydroxyl group. Okay. Number of hydroxyl groups are present on the or in the compound, not only in the compound. Okay. Because our functional group is nothing but what? OH in this case, right? So how many OH are present? According to that, we can classify it mono, right? Di or tri. What? Hydric. Because this hydroxyl group is considered as a hydric group. Okay. So if only one OH group is present into the compound, that would be monohydric. If it would be two OH groups are present, that would be dihydric. And if there would be the three OH groups are present, that is what? Trihydric. So for that example, I'll show you here. Monohydric is C2H5OH. What is the name of this compound? Ethanol.
Ethanol.
Okay. Then the next dihydric. Here it will be CH2, CH2. This is also derivative of ethane only. But then one hydrogen has been replaced with OH, another hydrogen here also replaced with OH. So here how many OH groups? 1 and 2. So this is called as what? Dihydric alcohol. Okay. And if there would be the propane derivative, in which each and every CH3 group, among the CH3, one of the hydrogen is replaced with OH. That is what? Trihydric. Okay, trihydric alcohol. Understood? It's classified on the basis of what? Number of OH group present into the given compound. You might have heard, you might have learned in your grade 10th as well. I think when you learn for the soap, that time glycerol you might have seen.
Yeah,
right?
ma'am.
Yes. The trimester of alcohols, that too you might have seen. Ester, trimester of trimester, not ester, trimester. Means what? 3 OH group has been replaced by 3 esterified group, right? Sodium salt of ester. Isn't it? That is the process of making of soap, isn't it? Are you able to recall it or not?
Yeah, ma'am.
Yeah. So those would be trihydric alcohol. If there would be only one OH, mono. If there would be two OH, that would be di. Clear? Yes?
Yes, ma'am.
Yeah. So the basic difference in between your phenol and alcohol is what? That I'll let you know. Shall I erase this or you're writing? Hello? Shall I erase it?
Yeah, ma'am.
The basic difference in between your alcohol and phenol, if we see. So if phenol, it would be, it's a benzene ring attached with OH. Correct? If you see one of the example of this would be suppose CH3OH. Correct? Yes? Now you can see this carbon is directly attached to OH. Means one of the hydrogen from the alkane is replaced with OH. And the nomenclature is already we have seen. You have to just consider your parent hydrocarbon, right? Suppose this is what? One carbon, so it is methane. Okay. So this E should be replaced with what? OL. Right? So the name of this compound would be methanol. Okay. And this would be phenol. In this carbon atom is sp3 hybridized. Right? And what about this carbon atom? it has a carbon-carbon double bond, right? And hence it would be sp2 hybridize. Understand? Means in your alcohol, your OH group is attached to sp3 hybridized carbon, and in your phenol, OH group is attached to sp2 hybridized carbon. Clear? Understood the basic difference in between both?
Yes, ma'am.
Fine. Now next. In that, few more things we have to learn about the alcohols. So alcohols can be allylic alcohols, it can be benzylic alcohols, right? Yes or no? Even it can be primary, secondary, and tertiary alcohols. So few examples we have to see for that. Clear? So primary, secondary, and tertiary alcohols we have to learn. In this, three types of alcohols are there. If OH group is attached to primary carbon, then it is primary alcohol. If it is attached to secondary carbon, then it is secondary alcohol. And if it is attached to tertiary carbon, then it will be tertiary alcohol. If we see example, suppose this carbon is attached to CH2, one of the hydrogen is replaced with OH. And here is only one R group. Okay. So this is your primary carbon. OH group is attached to your primary carbon, hence it is primary alcohol. And if suppose here is the carbon, which is attached to two alkyl group, only one hydrogen would be present. It is secondary carbon, and if it is attached to OH group, then such alcohol is what? Secondary alcohol. Right? And if there would be all three hydrogen would be replaced with alkyl group, and here it will be only one OH. One of the hydrogen is replaced by OH, that time it will be tertiary alcohol. Okay, primary, secondary, and tertiary alcohol. Clear about this? Yes?
Yes,
Now, what
ma'am.
is allylic alcohol? Allylic alcohol means these alcohols in that OH group is attached to a sp3 hybridized carbon adjacent to the carbon-carbon double bond. Don't get confused. Allylic means it does not directly attach to carbon-carbon double bond. Clear?
Yes, ma'am.
Understood?
Yeah,
Allylic
ma'am.
carbon is what that you need to understand first. Right? Most of the time what happens, student make a mistake over here only. Suppose this is a carbon-carbon double bond. Okay. And it is attached to your one of the sp3 hybridized carbon, and this will be attached to your hydroxyl group. Correct? So we need to satisfy the valency. This is satisfied. This is also satisfied. If you see here, 1, 2, 3 carbons are there. So 1, 2, 3 bonds are there. One of the bond is remains, so it becomes CH. And here 2 bonds are there. It will become CH2. Clear? Right? Valency is being clear. Now you can check. This is the sp3 hybridized carbon. So as it is sp3 hybridized, if it is attached to 2 hydrogen, it's a primary one. Right? So this allylic alcohol would be primary alcohol. So now tell me whether this allylic alcohol can be secondary or tertiary, and how? This allylic alcohol can be secondary or tertiary. If yes, how? Yes, Aditi? It can be secondary or tertiary?
It can't be, right? Because
Are you
OH,
sure? Right now, whatever structure I have drawn here, that is primary structure.
yeah.
Right? I don't have any doubt about it. But then what I supposed to do to make it secondary and tertiary, whether I can convert it into secondary and tertiary or not. If I can, what changes I should make in this compound?
By resonating it and shifting the CH2 group at the end towards the.
No, beta. What changes we supposed to make? In this case, see.
Or
But
we
you have
can just replace one of the hydrogens with a carbon group.
yes, yes. Here are how many hydrogens are there? Two. So one
Yeah,
of the
so we can add two more carbon groups, like methyl
yes,
groups.
one more carbon if you added instead of hydrogen. That time what happened? Means like suppose here it is CH. Here you have added suppose if you added here one of the R group, any CH3 group or R group, right? And it will be OH. That time this carbon become secondary carbon. Though it is allylic, here is a carbon-carbon double bond, that won't be changed. So it is allylic carbon, but then this carbon would be secondary. OH is directly attached to secondary carbon and hence it would be secondary allylic alcohol. Okay. And the same compound, if CH2 double bond CH, here it will be what? C, R. This another hydrogen also I have replaced with R and it will be OH. If you see this carbon now it will be tertiary, correct? So it will be tertiary allylic carbon. Understood? Yes. So though it is allylic alcohols, it can be primary, secondary or tertiary. Okay. Fine. Yes or no?
Yes, ma'am.
What about the benzylic carbons? Benzylic carbons are what? That can be primary, secondary or tertiary or not. If I have drawn here benzene, alternate double bond, okay? If here is one of the CH2 group, this is your benzylic group, okay? Benzylic carbon,
Yeah.
okay? And that should be attached to your OH, correct?
Yeah.
So when it is directly attached to CH2 group, it will be primary, correct?
Yeah.
Your benzylic carbon or benzylic group, right? Total overall if we see. Now, if this one of the hydrogen, if instead of CH2, if I write CH and one of the hydrogen is replaced with R, then it will be turned into secondary, correct? And if I remove this hydrogen as well, and here I have means like add one more R group or alkyl group, this benzylic carbon will be turned into tertiary. Clear? And as this carbon would become primary, secondary, and tertiary, your alcohol also can be turned into primary alcohol, secondary alcohol, and tertiary alcohol. Clear? Yes?
Yes, ma'am.
Understood, or I have to draw the structure for each and every separately? If it is so, let me know. I can draw that. That won't be a
No, ma'am.
problem.
I got it.
But it's too basic because of that only. I'm not going to go more deep in that. Fine. So we have learned about the like monohydric, dihydric, and trihydric on the basis of number of hydroxyl group, right? On the alkyl group, right? How many hydroxyl groups are present into the compound? The same we have to do for what? For the phenols, correct? If I have to classify the phenol, how I'm going to classify them, right? So in same way, how many hydroxyl groups are there? On the basis of that, we can classify them. Suppose if there is only one OH, this would be what? Monohydric, correct? Now here again a benzene. Here it will be a CH3 group and here it is OH. If you see the compound, though it is CH3, it doesn't matter. How many OH groups are present? Only one. So this is also monohydric. Here it is monohydric. This is also monohydric. Because this classification we are doing on the basis of number of OH group. Clear? Now if I have drawn the structure, this is the benzene. Okay. And if there would be two OH group, then it would be what? Dihydric phenol. Correct? And if there would be three OH groups, that will be what? OH, OH, and here also OH. This would be trihydric phenols. Understand? This is the type of class. This is a classification for phenol. Okay? Fine? Understood? Hello?
Yes, ma'am. Got it.
We have learned about the allylic alcohols. Now we learn about the vinylic alcohols. What do you mean by allylic and vinylic bonds? I already explained you last chapter. Allylic means what? Allylic means what? Carbon-carbon double bond, which is attached to one of the carbon and then it will be attached to functional group, right? Suppose OH. So this carbon would be allylic carbon, isn't it? Which have a adjacent double bond. This is what
Yes.
allylic. Okay. But then when there would be the carbon-carbon double bond is directly attached to your functional group, then this is what? Vinylic carbon. Understanding? Yes?
Yeah, ma'am.
Understood. So such kind of
Yes.
compounds are also possible. Such are vinylic alcohols. Now, if we have to balance the valency, that time carbon has a 4 valency, we know 1, 2, 3, and 1 is remains. So because of that, I have written here H. 1, 2, 2 are remains. So I'm going to write here CH2. Right? So this would be what? Vinylic alcohols. Right? Yes or no? So if OH group is bonded to the carbon-carbon double bond directly, that is called as what? Vinylic carbon, or that alcohols are called as vinylic alcohols. Understood? Now, one more thing about ether. Classification of ether also need to be done. We have done for alcohols. We have done for what? We have done for, I guess, this one, phenols. Now we are going to do for ether. Right? So for ether, general structure was ROR. This R group can be same or can be different. Right? When it will be same, that time ethers can be symmetric. Symmetric ethers. Right? And when it will be, when these R O or this two R will be different, R or R dash, that time it will be what? Asymmetric. Asymmetric ethers. Correct? Yeah. So ethers can be
Yes.
in the two groups. That will be the symmetrical ethers and the unsymmetrical ethers. Okay. For example, if it is CH3, OCH3, it will be symmetric ether. If it will be CH3, O, C2H5, it is asymmetric ether or unsymmetric ethers. Clear? Yes. Two groups attached adjacent to oxygen will decide whether it is symmetric or unsymmetric. Clear?
Yes,
Yes.
ma'am.
Okay.
Got it.
Shall I erase it?
Just a minute. I'm just copying the last two lines.
Wait.
Yeah, ma'am. Done.
Shall I erase?
Yes, ma'am.
Fine. Now we are going to learn about nomenclatures. For the alcohol, already I have told you, right? Yes or no? What we have to do? We have to just replace E from your parent hydrocarbon, alkane. Alkane, it will be converted into alcohol. How? This E would be replaced with OL. Okay, do not think about this. Alcohol is a kind of functional group. For example, suppose methane is given. Methane would be parent, in that E would be replaced with OL. So name of the formed alcohol would be methanol. Okay, for example, this is CH3OH. You have to find out the parent. What is the parent? Only one carbon, and hence hydrocarbon would be methane. E would be replaced with OL. So it becomes methanol. And the position of this OH also you have to show with the number. If it is attached to your first carbon, second carbon, third carbon. But then with methanol, there is only one carbon, so you need not to write. Or if you write methane one, all that too, fine. Clear? Yes?
Yes,
Understood.
ma'am.
Shall I give you a few examples? Can you write the name?
Yeah, ma'am.
Okay. I'll give you an example. Let me see whether you're able to write or not. I'm not going to give you much, only few I'll give. Let's see.
First one is propanol.
Okay. The next one.
It's 1-methyl propanol. The third one is tertiary butanol.
Tertiary butyl alcohol, that would be commonly, right? But then IUPAC name, you are not able to do, cannot able to give me, right? It will be isobutyl. Generally, if you see 1, 2, 3, 4. Commonly, it is called as isobutyl alcohol, right?
Yeah.
It will be what? N-propyl alcohol, commonly. And this would be what? Tertiary butyl alcohol, 1, 2, 3, 4 carbons are here. Correct?
Yes.
But then it's IUPAC name. For that, you have to first of all like check the longest chain. 1, 2, 3. And the numbering should be start from the nearby your functional group, right? Yes. So it is propane. Which number your functional group has been attached? First number of carbon. So E would be replaced with OL. First of all, you have to write it here dash propane. 1 number of the carbon where a functional group has been attached, and your prefix for the alcohol. So name of this compound would be propane 1-ol as per the IUPAC rule. Okay, the same thing we have to do for this 1, 2, 3. Correct? Yeah. So longest chain 1, 2, 3 here also same. 1, 2, 3 here also same. Correct? So that is again propane. Okay, it should be replaced. First number carbon connected to the functional group. So propane 1-ol. But then this substituent is there, that is at the second carbon. So 2-methyl propane 1-ol. Clear? Yes? Hello? Are you
Yes.
there?
Yes, ma'am.
For this, what you're going to do? You can number from any side, like it will be 1, 2.
Yeah. So it will be 2-methyl to
This
propan
will be
2-ol.
1, 2, and 3. Longest chain you have to check, right? If it number 1 and 2, it will be just 1 and 2, 1 and 2. Longest chain you have to select. So this would be the longest chain, I guess, in this compound. Yes? High number of carbons are contained. Yeah?
Yes.
So 1, 2, 3. So second number of carbon is attached to your functional group. So propane would be your, again, what? Parent hydrocarbon. Second number of carbon is attached to OH. So 2 OL, propane to OL. But then your second number of carbon is attached to methyl group. So it will be 2-methyl propane to OL. Clear? Understood? Hello, Aditi. Are you writing?
Yeah, ma'am.
Okay, fine. Shall I give one more example?
Sure,
Can you-
ma'am.
Fine. Fine. So one more example would be in this way. CH2, 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 OH, OH, OH. Let me see how you're going to do that. Quite different, right? Generally, it is what? It is ethylene glycol. General name, it is
Yeah.
ethylene glycol. Okay, and this will be what? Glycerol. Its general name is what? Glycerol. What would be the IUPAC name? Same way, you have to see the longest chain of carbon. This will be the longest chain. Each carbon has one hydroxyl group. Okay. So 1, 2, 3. Either you can start from here or there. Doesn't matter. Right. So parent would be what? Your propane. Correct. Right. So E should be replaced with OL. But then we have here how many OH group? 3 OH group, right? Yes or no? How many OH groups are present in this? 3. Right. So we cannot
Yeah.
write OL. That will be what? Triol. Triol. Okay. But then position need to mention for this triol, right? 1, 2, and 3. So propane 1, 2, 3 triol. This would be the name for this compound. How are you going to write? Propane 1, 2, 3 triol. Ol for alcohol, tri for 3, and the position of this 3 OH group would be 1, 2, 3. Means 1, 2, 3 carbon contain OH group. Understood? In the same way, can you please name this compound ethylene glycol? There would be 2 OH group instead of 3. So it become what? Instead of triol, what is
Ethane,
diol, right?
ethane 1,2-diol.
Very good. Ethane 1,2-diol. Understood? It will be what? Ethane 1,2-diol. Clear? Now, if alcohol would be in this manner, shall I erase it? Shall I erase it or you're writing?
You can erase it, ma'am.
If I'm giving you the structure in this manner, how are you going to nomenclate it? Whenever cyclic alcohols are given to you, whatever numbers are there, number of carbons, okay, that you have to find out. Parent hydrocarbon you have to see. But then before like writing the name, you have to just add the word cyclo in front of it. Means if you see, how many carbons would be present in here? 1, 2, 3, 4, 5, 6. So this is hexane. 1 ol, right? But then what it is in a cycle, because of that you can write it here cyclohexane 1 ol. Understood? Or commonly you can call it as cyclohexanol. Okay. Hello, are you there?
Yes, ma'am.
Now what would be the name for this? 1, 2, 3, 4, 5. This is pentane, right? So it is cyclic form, so cyclo pentane 1 ol. At the second position, methyl group is here. So 2 methyl cyclopentane 1 ol. Okay. Understood?
Yes, ma'am.
Shall I erase it?
Sure, ma'am.
Now we are going to see the nomenclature for phenols. Okay. Now for this, see, this is a normal structure of phenol, right? The benzene ring attached to your hydroxyl group, sp2 hybridized carbon. Clear? Right? Now, if I have add one CH3 group on this phenol. So commonly it is called as what? Cresol. What does it called? Cresol. Okay. So position of your hydroxyl group or your methyl group to the adjacent each other. These two substituents will decide the name. Now you can check these substituents are ortho substituted to each other, right? Adjacent to each other. So it will be what? Orthocresol. Okay? Yes or no? Now, if in the phenol or the CH3 group at the CH3 group and your hydroxyl group at the meta position to each other, then its common name would be meta-cresol. Okay? And if it will be at the para position, then it will be called as what? Para-cresol. And these are the common names. So what would be IUPAC name for this? Yeah? Common name for phenol is phenol only. There won't be any change. IUPAC name what? For that you have to number it. Right? Yes or no? So we know that this is nothing but what? Phenol for the IUPAC system and even for the the common system, right? So here is the phenol group is present. Right? Yes or no? So we are going to start numbering from here. 1, 2, 3, 4, 5, 6. At second position, your methyl group is present. So what would be the name for the orthocresol? 2-methyl. Come on, tell me. 2-methyl. What is this substituent overall? Phenol. 2-methyl phenol. Correct? Yes or no? Here is also, this would be the phenol group. Right? Numbering will start from here. 1, 2, 3, 4, 5, 6. At which number methyl group is there? 3. So it will be what? 3-methyl phenol. Right? And if you see, this is a phenol. So numbering will start from here. 1, 2, 3, 4, 5, 6. Correct? At the fourth position, your CH3 group is there, and hence name is 4-methyl phenol. Clear? Yes, Aditi?
Yes, ma'am. I'm just
Yeah,
noting them
understood?
down.
Sorry? What
I
you
said I
said?
was just noting them. I was
Okay, okay.
noting them down.
Please note down, note down. No issues. Now there will be the dihydroxy derivatives are also present in the phenol. Means on a benzene there will be 2 OH group would present, right? And that nomenclature also you should be known how you have to label it. That too I'll show you. Note it down first. If you have done, let me know so I can erase it. Beta? Aditi, shall I erase it? Aditi? Hello? Am I audible, beta? Aditi?
Ma'am, your voice is breaking.
Yeah. Am I audible now?
Yeah, ma'am.
Fine. So can I erase it now?
Yes, ma'am.
Fine. So, like if there would be the diol in the like one two hydroxyl group in a phenol, that time how you supposed to name it. And what would be the common name for same? I'm going to give you catechol structure. This is the benzene ring. Okay. And if 2-hydroxyl group is present on the benzene, that is commonly called as the catechol. Okay. What does it called in the common? Catechol. Okay. If it is at the ortho position. Okay. If 2-hydroxyl group at the ortho position or phenol group at the ortho position, that is called as catechol. If it at the meta position, then it is called as what? These name you need to keep it in your mind. Huh? Though it is not IUPAC name, this one you need to keep it in your mind. This is called as risosinol. Catechol means ortho, risosinol means meta, and then hydroquinone means para. Okay. Right? This would be hydroquinone. Now, how you're going to label it in IUPAC way? Numbering you should do. This is the benzene, correct. This is the benzene, correct. This is also benzene, correct. We cannot consider it as a phenol, right? Earlier we have seen phenol, right? Because another alkyl group. Another substituent wasn't OH group. That wasn't a hydroxyl group. That was just a alkyl group. And hence, because of that, we have considered the phenol. But then here we are going to consider what? Only benzene, because 2 hydroxyl groups are there, right? So if you label it, number it, anyone you have to choose. Suppose I have started from here and I have to go clockwise. And I have to go clockwise.
So it'll be 1, 2.
Huh?
The numbering. It'll be 1, then 2.
Yes, yes. We have to number it. But then how are you going to number? Like both groups should be nearby with each other in a numbering.
With the least, like the total sum
Yes.
should be the least.
Yes. So 1, 2, 3, 4, 5, 6. I can come in this manner as well, but then that would be wrong. I can't come in anti-clockwise in this structure. If OH group would be at the left-hand side of the OH, that time I could do that. Means anti-clockwise, I could number it. But then here it is at the right side, and because of that, I have to go clockwise. Understanding? Okay. So it is 1, 2 position, 2 OH group is there. And we have already seen the phenols nomenclature, means like classification. If there would be 2 OH group, that is called as diol. Right? If there would be 2, 3, there would be 2 OH group, that is called as diol. If there would be 3 OH group, that will be called as triol. Right? Now it will be what? Diol, isn't it? Because 2 OH groups are present in that. So your benzene is a parent here. Okay? And on the benzene, at the first and second position, what is present? Hydroxyl group is present, OH group is present. How many? 2. And because of that, it is diol. Benzene, 1, 2, diol. Understanding? Means benzene structure is there. At its first and second position, what you have to do? You have to add OH group, means diol. This would be the structure for catechol. Now, what would be this? Benzene, numbering would be 1, 2, 3. Instead of 1, 2, what you're going to write here? 1, 3. Diol. Correct? Yes?
Yes, ma'am.
And here it will be 1, 2, 3, 4. So it will be what? Benzene. 1,
1, 4 diol.
Diol. Understood? Yes? Easy? Understood?
Yes, ma'am.
Shall I erase it now? If you're writing, it's fine. Let me know.
No,
once.
ma'am, I've copied it.
Fine. Now see the next, which is given to you. That is about ether. Common name of ether already we have seen, that will be alkyl or aryl group, whatever would be attached to the OH, that need to be written. Right? Yes or no? Means like ethyl, methyl, ether we say. CH3O, C2H5. What would be the name of this compound? Commonly ethyl, methyl, ether, right? This side it is ethyl, this side it is methyl, and in between both oxygen is there, bonded oxygen with the alkyl group, and hence it is ethyl methyl ether. It's a common name, isn't it? Yeah? Yes or no? Hello.
Yes, ma'am. Yeah, ma'am.
So what would be the IUPAC name for this? In common name, you might be thinking like, ma'am, why you are not taking methyl first? Why you have taken ethyl only first? So it's because of the alphabetical order. Keep it in your mind. E would come first before the M in alphabet. Because of that, ethyl methyl ether. You can't say methyl ethyl ether. Okay. This is common name system. Right?
Is it methoxyethane?
Yes. Correct. It would be methoxyethane. And this OCH3 group is what? A common. That is what? Methoxy group. Right? And this is your ethane. The name would be what? Methoxyethane. Right? If it would be structured in this manner, CH3O, CH3, that time it will be what? Commonly dimethyl ether. It's a common name. And IUPAC name would be what? Methoxymethane. Why? Because this OCH3 group is methoxy group. And it is attached to which parent alkane? Methane. So it will be methoxymethane. Okay? Suppose instead of CH3, C2, so CH2, O, and CH2, CH2, CH3. Then in this case, what you will check? This will be your ethoxy group. And this is your propane, correct? Yes or no? The name of this compound would be ethoxy propane. Understand? If oxygen you are considering with this, that time you need to check which alkyl group is present near to it. Whether it is your methyl group or whether it is your ethyl group. Clear?
Yes, ma'am.
One more example I'll give you that is quite different. Here. C6H5O attached to CH2CH3. The name of this compound would be what? Commonly it is ethyl. Sorry, this would be ethyl and this is phenyl ether, right? This group is what? Ethyl group, correct? And this group is what? Phenyl group. So common name would be what? Ethyl, due to alphabet would come first. Ethyl, phenyl, ether. Common name. What would be your IUPAC name? In IUPAC name, you have to consider, I'll change the color. You have to consider this group together. This is O, I'm sorry, not this one. This is phenyl, na? You have to consider this group together because it's the lowest hydrocarbon, right? OCH2, CH3 means it is ethyl group attached to O. It becomes ethoxy, correct? And this is what? Benzene, C6H5, isn't it? Yes, phenyl ring is nothing but what? Benzene ring.
Yeah.
Which is attached to oxygen, right? So it is ethoxy benzene. Clear? So this would be your IUPAC name. Understood?
Yes, ma'am.
Yes. So few questions of the nomenclature I'll post to you in a group directly after some time. Okay. Try to solve it. Clear? I think time is up. We will continue for the same chapter tomorrow as per the timetable. Okay.
Okay, ma'am.
Yeah. Take care, beta. Bye bye.
Bye, ma'am.